recording. So hello everyone, let's start with the demo. So this is the demo of the end of 1821st sprint for Indy Node and Indy SDK teams. So the current sprint of Indy Node team was devoted to stability fixes, new stable release, and investigation of memory consumption problems. As for Indy SDK, it was devoted to lib VCX integration and dummy agent implementation, as well as other fixes and improvements. And today's demo are going to describe in more details these items, in particular from Indy SDK team. Sergey Minaev will tell us about reducing common build times. And Nemanja will describe the recent progress regarding VCX integration. As for Indy Node team, Sergey Shilov is going to present new findings in DRAM-Q memory consumption. And Renata is going to describe one of the issues that was fixed, and it's also related to memory consumption and backup instances. So, Sergey, you can start.
Thank you, Alex. Hello, everyone. Let me share my screen. Today I would like to provide some details about Indy SDK continuous integration, continuous delivery, and especially about some specific for our large project. As you may know, there are a lot of components and inside Indy SDK repository, and we have a single and common continuous integration, continuous delivery pipeline. Also, the major note here that we're testing our product at a lot of platforms, for example, on Ubuntu, Red Hat, macOS, Android, iOS simulators, etc. Let me first describe how it was organized previously and point out some problems in the old implementation. Now you can see a diagram for continuous integration. It's the most interesting part of libindy, and I would like to consider in details part of Linux testing because this part is most complex and contains the most count of steps. We have two platforms for Linux testing. It's Ubuntu and Red Hat. It's mostly similar, and only one difference here that we reduce some wrappers on Red Hat testing. Also, we have Windows and macOS testing in parallel. So, in general, when Indy SDK continuous integration started, we run several parallel tasks. One for Ubuntu, one for Red Hat, one for Windows, macOS, iOS, Android. And in previous implementation, we allocate Jenkins worker for Ubuntu tasks and perform some steps like building libindy, building nullpay plugin, and our large test procedure contains tests for libindy itself, different wrappers, CLI, VCX, and of course it's too long and too much time required if we would like to start it consequently, so we run it in parallel. Previously, we use already allocated engine to implement, to run libindy tests, and also allocate additional agents for each wrappers, as you can see on this diagram. The problem here is allocated agent for libindy building and for libindy testing are waiting for finish of all wrappers. It's not a problem when then only one continuous integration is run on Jenkins at one time. But if you have parallel PRs or parallel continuous delivery and continuous integration, may be a problem. While my instance for Ubuntu testing, for example, running libindy tests and build and finish this work, this instance will still waiting and be blocked until other wrappers are finished. So in some meaning, we have some kind of deadlock here. Now we change this behavior and new schema and new consequence of steps you can see on new diagram. Now we start Ubuntu testing and separate two parallel branch of interaction of running this pipeline. In first part, we built libindy and null pay for some testing, and marks that build ready and wrappers can be and testing can be started for wrappers. So after it main Ubuntu runner for test working on libindy testing and released right after testing libindy and don't waiting wrappers. So we avoid deadlock now, and actually it means that for high load on our Jenkins infrastructure, we save at least 2 instances per work. In meaning of time, previously our build took about 2 hours at least, and now our time reduced twicely, so our standard continuous integration pipeline now finished during 1 hour. Also, I would like to add one note that we reduce amount of Android test, and now the most complex and most long way in this schema is Android, and it took about half of hours for building and half of hours for running the test. Probably our next steps for improving continuous integration, continuous delivery build time is researching some ways to use hardware emulation of Android on Amazon infrastructure. That's all from my side. Thank you.
Thank you, Sergey. So the next demo is from Nem, and it's about VCX. So Nem, you're welcome.
Thank you. Let me just share my screen. This should be good. Okay. Where am I? Okay. So we had a ticket. So you hear me well, yes?
Yes, we can see it.
Ah, sure. Cool. So we had a ticket to remove all of the static compiling of payment plugins from VCX. How it works right now, at the current moment, is that the logic and the payment plugins are statically compiled into the libvcx binary, so that, let me just show you how it looks and what are the differences. So this is not fast enough. Okay. So where is it? Okay, I cannot find it here, but okay. So what happened? How it's working right now? We have configuration options like null pay and subtoken that are provided into the build scripts that are building the libvcx artifact, and based on that, these fields and methods are defined. So a method init for null pay is defined, an init method for subtoken is defined, and all of the corresponding method names and logic, so that all of that information is so in the binary when connect.me or Verde UI are using it. So there is no way of changing the plugin at runtime. Everything is hard-coded. Basically, subtoken is right now hard-coded in the code, and it's sitting in Hyperledger repository, and Hyperledger has said they don't want these kind of things, mentions of proprietary tokens or tokens that somebody else or some company developed, and nothing that's not generic enough. They don't want it in Hyperledger repo, so we had to remove it. So how it's doing right now, so it hard codes, it set up the payment plugin registers to libindy, and the code just continues using these methods. What we did is we removed all of the static compiles, we removed the flags, and we just said that the loading of the plugin and initialization of the plugin is application's responsibility. So if we have Verde UI, if we have connect.me and Verde UI have to decide in what way they want to link with the payment plugin, and what way they want to load it, and in what way they want to register it. The only thing that's left in the libvcx is that you just provide a configuration option that defines this method that was hard-coded, and based on that payment method, you just continue working. So this is the function that we changed, and we just said, so there is VCX in it, and we said if you want to initialize the VCX, you just have to provide it the payment method. You have to provide the payment method inside the configuration that's provided. And that's it, basically. That's how we removed the static compiles, removed all of the subtoken mentions from the code base. Now Hyperledger is happy, but our colleagues that are working on connect.me and Verde UI are not so happy, but we'll kind of fix that. And what had needed to be done also, because everything was relying on hard-coded values and hard-coded payment addresses and methods, we refactored all of the tests. Now all of the tests are generic enough. We have still some hard-coded things because of the logic in which the tests are written and the code base is written. Defaults had to be hard-coded, and tests are now using libnulpay as defaults. And if tests were to be used if you want to use tests with any other payment plugin, you would have to do a change in the code base and just change the names and these defaults. So right now they're referencing libnulpay. They say that the payment method is libnulinit and the payment method is null. But probably in the near future, this will be fixed in a way that every test will read some test configuration that is provided when the tests are being run. So all of these information will not be hard-coded in code base or in these RS files, but rather will be in some JSON or TOML that is provided to the tests. So that's kind of it. Now, for tests to be able to run, they require the plugin to be loaded, so we had to write a plugin. So a method that will load the plugin and init the plugin based on the defaults that I mentioned earlier. And that's about it. So the next steps that we have to do is to agree if this approach is acceptable for the Verde UI and connect.me guys, and to see what additional tickets or changes need to be done. we also need to refactor the tests to be more flexible, to not expect certain things to be hard-coded, because right now that would be a major refactor, because everything is kind of was written in a way where you always think that certain things are there, but they might not be. And that's it. That's the demo.
Okay, thank you, Nem. Now let's move to Indy Node part, and Renata, you're welcome to start.
Hello, could you see my screen?
Yes.
Good. Today I will talk about how problem is memory leak and how we solve this problem. In cases of successful ordering on all instances, the request is removed from the queue. But in the case when something went wrong and the transaction is not ordered, the request will always be in the queue. It's a memory leak. What can go wrong and what can we do about it? We have several strategies. First, remove the replica if the backup primer is connected. Second, remove replica in backup performance degraded. And finally, remove replica by quorum of messages. So firstly, transactions will not be ordered on a backup replica if primary nodes for backup is disconnected. If the connection is not restored within a minute, the replica will be removed. Second strategy, if for some time on some backup instance the number of ordered transactions less than on other instances, or there are no ordered transactions at all, the replicas in the instance are removed. And third strategy, if a node finds one of these problems, disconnected or degradation, with its backup replica, it sends a backup instance fault message to all nodes. And the nodes remove replicas only by the quorum of these messages in the amount of f+1 messages. And in the scope of this task, we added two configuration parameters for disconnection and for primary degradation. It can be local when nodes remove replicas without quorum, quorum or none for switch off logic with removed replicas. According to the results of first testing, the queue of requests is cleared and memory usage doesn't increase. That's all. Thank you. Any questions?
Thank you, Renata. And the last demo for today is from Sergey Shilov, and it's about RMQ memory consumption.
Hey everyone, can you hear me, please?
Yes, we can.
Okay, let's start. And I'm going to talk you about our findings and our investigation of memory consumption by the RMQ library. And first of all, let me describe some technical details on how the RMQ library deals with inner message queues, as it is the main point of memory consumption. Some of them we got from official RMQ docs, and others were investigated during our tests. In this presentation, we consider just router type of server RMQ listener socket. So let's start. For each connection, the RMQ library creates a separate message queue. It's a known fact from official docs. And during our test, we found that listeners receive function acts in a round-robin manner. So in this case, in case of big number of connections, the message queues may be kept in memory for such a long time, as we have a quote for the number of listener reads. Another one found feature is that a message queue is not cleared in case of closed connection from the client side. For example, in case of some timeout, if there are messages in this queue. So this is another thing that affects memory consumption. Let's talk a little about the test when throughput of the server was lower than overall throughput of clients. Our simple server was written in C, and on the first stage, when the test was run, server's memory usage grew up to 20 gigabytes of virtual memory and 5.5 gigabytes of resource usage. Then load was stopped and we let the server read all messages from queues. Then all messages left, so receive function started finishing with the game error. We observed that our C server still keeps about 4 gigabytes of virtual memory and 1.5 gigabytes of resource usage. And after some time, idle time and small and short load from clients, the C server reduced memory consumption to about 250 megabytes virtual memory, and 64 megabytes of resource. So it looks like there is some additional memory management from made by ZeroMQ. So the conclusion is that it seems like ZeroMQ library is not designed for high load with big numbers of connections. The inner queues management and observed long keeping of memory by ZeroMQ library may cause very large memory consumption under high loads. So this results of our investigation. Thank you very much.
Thank you, Sergey. Yeah, so yes, this is also proves one of our decisions and planning a roadmap to replace ZeroMQ, at least for client node communication, by something else, maybe HTTP, since it's maybe much more scalable and may fix all these problems. Okay, so thank you, everyone. Let's now quickly discuss the plans for the next sprint. For the next sprint, 22 sprint for Indy Node, it will be devoted to more investigation about memory leaks, about memory consumption. In particular, we would like to try to do a couple of tests and try to somehow reduce the consequences of ZeroMQ behavior that Sergey just presented by just limiting number of connections, something like this. And yes, we would like to also to prove that there is no other leaks for sure. Another goal for the next sprint is to have a next stable release of Indy Node 1.6.79. And this third goal is to continue working on bug fixing. As for Indy SDK, the goals of the sprint is to continue working on CI/CD, in particular libVCX related part. The second thing is it's actually to continue work on libVCX integration. Second thing is working on Rust wrapper for libIndy, and the third goal is to continue working on bug fixes. And libvcx also assumes finishing the work about dummy cloud agent needed for integration of VCX. So that's all. Does anyone have any questions about the demos, the plans, and the progress? Okay, if there are no questions, then thank you everyone, and let's meet in 2 weeks.
Hey, thank you, everybody. Good job. Thanks, Alex.
Thank you.